Let's talk about energy. Energy cannot be created or destroyed. It can only be stored and transferred. The two types of energy we will talk about in this video are gravitational potential store and kinetic store. Let's first look at an example to explain these two types of energy store. Take this ball for example. It has a mass m and it is 10 meters above the ground. This ball has no kinetic store. This is because it is motionless, and an object only has kinetic store when it is moving. However, it does have gravitational potential store. We can think about this as it has the potential to move if the ball were to be dropped. The amount of gravitational potential store it has can be calculated using the following equation. It is equal to the mass times its height times the gravitational field strength, which is a constant equal to approximately 9.81 meters per second squared, but for the GCSE purposes, this value is simplified to 10. Let's now perform a thought experiment. What would happen to the energy of the ball if we moved it up to the height of a skyscraper? The kinetic store of the ball would still be zero, since the ball is still motionless. However, since its height above the ground has increased, its gravitational potential store would have also increased. Now let's take another example. Say we throw the same ball along a straight line through air and ignore the effects of gravity and air resistance. This ball is travelling with a speed of v equal to 10 meters per second. The gravitational potential store will now remain constant throughout this whole motion, since its height isn't changing, meaning the equation for gravitational potential store will also remain unchanged. Its kinetic store, however, is not going to be zero anymore, since the ball is now moving. The amount of kinetic store this ball has is given by the following equation, which is equal to a half times the mass of the ball times its velocity squared. Let's now look at a real life example, where here we have a clip of a ball being thrown upwards, then coming back down. We assume that there is no air resistance which opposes the motion of the ball. At the very beginning of the motion, the ball's energy is solely kinetic, which sees the ball move upwards. There is no gravitational potential store here, since it is at ground level and therefore the height above the ground is zero. In the following bar charts, you can see how the kinetic store and gravitational potential store change during the upwards motion until it gets to the top. At the top, all of the initial kinetic store which the ball had at the very start of the motion has been transferred into gravitational potential store. This leads to the kinetic store being equal to zero, since the ball is motionless at the top, and from the equation for kinetic energy, if velocity is equal to zero, this leads to the total kinetic energy to be also equal to zero. As the ball falls and comes back down, the gravitational potential store transfers back into kinetic store up to the point at the very bottom, just before hitting the ground, where the ball no longer has any gravitational potential store, since it has all been transferred back into kinetic store, leading to the kinetic store of the ball at this point to be equal to the kinetic store which the ball had at the very beginning of the motion. At which point does the ball have no kinetic store? Pause the video and choose your answer.